So ATP synthase is the enzyme that is located at the end of the electron transport chain, and it's responsible for pumping or translocating H plus to generate ATP. So we can note over here that ATP synthase, it has three main components. It has the F1, the shaft, and the F0. The F0 is bound to the enzyme, and it's essentially the proton pumper. The shaft is in between, and the shaft rotates as F0 rotates. And when the shaft rotates, it causes a conformational change in F1, and in F1 we'll see the synthesis of ATP. But here specifically we're going to focus on F0. So F0 is over here at the bottom, and we're just going to zoom in and look at what's going on in F0. So first of all, we have to make note that we have a C ring, we have an A subunit. The A subunit has an asparagine, so we can actually see that right over here. We have an asparagine, and the C ring is made up of aspartates. And the asparagine is going to protonate our aspartate. And every single time the aspartate gets protonated on the C ring moves one forward. Okay, so for every aspartate that gets protonated, we move one forward, we move one forward, we move one forward, until we reach the very end. And at the end, we see serine. And serine is going to deprotonate our aspartate. So essentially, we're moving in a circle, and at the end of the circle, the proton has been transported from the intermembrane space side to the matrix side. So remember that the ATP synthase is located on the inner membrane of the mitochondria. And in the intermembrane space, we see a higher concentration of protons because that's where they're being pumped. Since that's where they're being pumped, we see a more positive charge, so it's referred to as the positive side, the P side. And on the matrix, we have less protons, so it's going to be the N side, so it's more negative on that side compared to the intermembrane side. So essentially, so F0, remember, it's bound to the membrane. So since it's bound to the membrane, I'll draw out this depiction. So if this is our membrane, these are our phospholipid heads. F0 is bound to the membrane, and then F1 is just sticking out. So F0 is exposed to both the intermembrane space and the matrix. And essentially, it picks up a proton from the intermembrane space, and it moves it over to the matrix, okay? So that's what's happening. The asparagine on the A subunit protonates aspartate on the C ring, and aspartate moves the H plus along the C ring until it reaches the serine, and the serine deprotonates the aspartate, and the H plus is released onto the matrix side. And then once again, the aspartate becomes deprotonated, and it moves back to be protonated by asparagine once again, and the cycle continues. And that's essentially how the translocation of H plus works on ATP synthase. So it happens on F0, and we can see F0 is, as a result, rotating. And this rotation of F0 causes the rotation of the shaft, and as a result, the rotation of the shaft causes the conformational change in F1, where we see the production of ATP.